Next idea that we want to discuss in this section is what is called the change of base formula. Now, before we talk about what the change of base formula does, I want to take a minute and explain to you what your calculator can help you calculate in this section. So I have two problems here. First of all, I have log of 5, and then I have a problem for the natural log of 8. So you want to kind of keep in mind that in terms of your calculator, that your calculator can work a problem for you that has a base of 10 or a base of e. So if you have a problem that has base 10 or base e, you should definitely be using your calculator to calculate those answers. All right, now looking at our first problem, we have log of 5. Remember that we talked about in class that if you do not have a base listed, okay, remember your base is your subscript that sits right here. If there is no subscript sitting right there, then we assume that that is a base 10. So I'm assuming that this problem is log base 10 of 5. And so again, definitely something that I can use my calculator for. I have a screenshot to the right. The first one is the one that we're looking at. You have a button on your calculator that says LOG. We'll press that button and then press the 5 and press enter. And I will probably ask you to round these things to 2 decimal places. So in this case, we're going to end up with 0.70. All right, for the natural log of 8, again, this is a base e. We talked about the fact that the natural log is the same thing as log base e. And so you have a calculator button right here for the natural log. And so if you want to evaluate the natural log of 8, we'll just press that LN button, then press the 8 and press enter. And again, we'll do 2 decimal places. So we're going to end up with 2.08 for the natural log of 8. All right, so let's move on. Now, these 3 problems are going to require either methods that we've already talked about in class or this new idea for change of base. So I'm going to begin with log base 5 of 25, and I believe that we worked this one in class, but I just want to review it with you. Remember that we said that our goal was to, first of all, set the problem equal to x. That was step 1. Step 2 was to write the expression in exponential form. So I'm going to start with my base, which is 5, go to the other side of the expression and get my exponent, and then come back to the left and get 25. And we said that in a lot of cases, you could simply look at this and say, oh, x would have to equal 2 in order to make this a true statement. If for some reason you can't do that, then you would look at writing both sides with the same base and then setting your exponents equal. All right, so let's go ahead and look at the next one. So we'll do the same process on the next one. We're going to set it equal to x. We're going to change to exponential form, so it will become 5 to the x is equal to 89. But the problem becomes, I don't know of a power of 5 that is going to give me 89. Nor am I able to write both sides of the expression with the same base. And so at this point, I sort of get stuck with this problem. And this is where change of base comes into play. So what I'm going to do is I'm going to take my exponential equation. I'm going to come over here so I have some room. I'm going to take my exponential equation. And what I want to do is I want to put a log on both sides of the equation. So I'm just going to write the word log in front of the 5 to the x. And then I'm going to write the word log in front of the 89. Okay, so this is the first step in change of base, is that you take the log of both sides. Now, you can choose the base that you want to use, but the only base that makes any sense for us to use is base 10 because that's the one that our calculator will do. So you can either put the little 10 right here, or you can leave it out entirely and assume that it's a base 10. But the first step, again, is to take the log of both sides. The second step is to use your properties that we talked about at the beginning of this section. Remember that we have a property that deals with exponents that essentially says that this x exponent can be brought down to the front of the equation. So I'm going to do that. So I have x in the front, and then I have log base 10 of 5 equals log base 10 of 89. And then my final step is going to be to solve for x. So in order to solve for x, in order to get x by itself, I'm going to need to divide both sides of the expression by log base 10 of 5. All right, so when I do that, it's going to cancel over here, leaving me x. And on the right-hand side, it's going to give me something that I can put in my calculator. All right, so in my calculator, and I didn't do a screenshot here, but in your calculator, just like we looked at before, you want to type in the log button and put the 89 in parentheses. Then your divided by key, the log button again, and the 5 in parentheses. All right, so when you do that, you should get 2.79. And again, we're going to do 2 decimal places. So I've already rounded that. 2.79 will be my answer. So it's important with change of base that you know 2 things. First of all, that you know when you need to use it. Okay, you need to use it in a situation where you basically get stuck working a problem out. It's not like a 5x to the 25 when you can just say, oh, the x is equal to 2. It's not like a problem where you can write both sides with the same base. Right? If neither of those methods work, then you should be thinking about change of base. The other thing that you need to know is how to use it. So remember, from your exponential equation, you're going to take the log of both sides, you're going to bring your exponent down, and you're going to divide. Now, I'm going to go ahead and look at this third example. And at first glance, this example seems kind of difficult because it has a square root of 2 as the base, and it has a square root of 5 as the term. Keep in mind that if you're using change of base, the calculator is doing the work for you anyway. So probably the fact that we have radicals in this problem is not going to make it any more difficult. All right, so I'm going to set it equal to x. I'm going to change it to exponential form. So I start with my base, I raise it to the x power, and I set it equal to the square root of 5. Now, obviously, I do not know a power of the square root of 2 that is going to equal the square root of 5, nor can I write both sides of this with the same base. There are no common bases between 2 and 5. So I'm going to do change of base. Remember, step 1 is to put the log on both sides of the equation. Step 2 is to bring your exponent to the front, so the x comes down to the front on the left-hand side. And then the third step is to divide, to solve for x. So we divide both sides by log square root of 2. Then we use our calculator. So again, you're going to type in log, and you're going to do the square root of 2. Make sure you close your parenthesis when you finish the square root of 2. Then you're going to divide, well, actually the square root of 5, sorry. We're going to do log of the square root of 5, and be sure that we close our parenthesis after we do the 5. And then we're going to do the division key, and then log square root of 2. And again, be sure you come out from underneath that square root and close your parenthesis. And you should get, rounded to 2 decimal places, 2.32.